So, welcome to the second lecture on collective intelligence in organizations. And this time we're going to dig a bit deeper into the perspective of organizations as being sort of the sum of all the microsystems of the organization. So this new perspective on organizations we're trying to introduce here is looking at them as an ongoing series of parallel microsystems. Imagine a larger organization of, say, 1,000 employees. As you can understand, such an organization would then consist of, let's say, 3,000 microsystems per day if every employee on average attended 3 microsystems per day. The interesting thing with this perspective, though, is that we can start looking at factors influencing organizational performance, but that organizations tend not to care about or address today. Factors influencing organizational performance, but that are not caught by, let's say, traditional structural tools of organizing. Examples of these new factors that we can start looking at is, of course, things like physical status. Of course, microsystems would vary in their performance level depending on such a simple thing as the physical status of the participants. We can easily understand how tiredness, stress, and things like that can reduce the quality of knowledge integration. And that is basically the purpose of the organization. And these physical factors become a relevant factor if we look at things from a microsystem perspective. Things that like feelings and emotions and relations. We can understand that bad feelings in relation to a meeting can influence the outcome as well as the opposite, of course. People having different perspectives is another thing that is related to this. The way people actually think about their organization and think of the situation is perhaps one of the most important factors for their ability to collectively create intelligence. We'll come back to that later on. It's called a representation. That is the understanding I have of the situation. By understanding how that influences knowledge integration at microsystem level, we can make that more workable than it is today. Our point here is that if we look at the sum of all microsystems, we can understand how all these factors can influence overall organizational performance. And by introducing that, organizations can also start creating strategies for these factors. Strategies, you could say, for improving the average collective intelligence level of the microsystems. So, now an important question then. That is, of course, how big is this problem, or what kind of variation are we talking about here? How good are we at cooperation? The answer to this question would indicate what potential organizations would have if they developed a strategy to increase their microsystem skill level. And here we have collected a number of examples from experimental studies. Let's start by looking at them. And then we can see that something that is by a lot of people sort of connected to the idea of working in groups is, of course, brainstorming. The idea that we are using our different knowledges and experiences and together we can come up with ideas and create things that none of us could on our own. But if we study this in experiments, we see that actually groups that are trying to cooperate and are unfacilitated, they always are outperformed when it comes to the purpose of brainstorming. That is in the respect of developing ideas, the quantity of how many ideas that are developed, but also the quality of the ideas. And they're outperformed by what's called nominal teams, which is basically you have the same number of people, but they don't try to cooperate or discuss these ideas, but they develop them on their own, and then afterwards they are compiled into sort of the group result. The only time when cooperative groups or groups trying to cooperate actually can perform at least at the same level as nominal teams is when we using an IT tool or facilitators anonymize the exchange of knowledge, which is interesting in itself because that sort of indicates to us the influence of social factors. Who is saying what? We'll come back to that later as well. Now, another way of looking at this is to see how good we are at solving what's called well-structured problems in teams. Well-structured problems are problems that, in a sense, you could say are always simple. Even if they're very difficult and very advanced, they're simple in the sense that it's limited what you need to care about. So it's a well-structured problem. You have these resources, you have this problem, you have this amount of time to solve it, and so on and so on. Which, of course, is not, the conditions of real life. But if we look at groups trying to solve well-structured problems, we see that on average the group result is to perform at the same level as the second best individual in the same group do on his or her own. And of course you can ask yourself, well, was that a good or bad performance level? Well, of course you can say it's an improvement in relation to what the average individual do on their own. The second best individual is normally better than the average individual in the group. But if you think about it in terms of resources, it's quite a waste, right? Because it means that if we could identify the best and the second best individual, they could do and solve this problem on their own, and we could let the rest of the group do something else. Now, a bit sadder in a sense is the results we have from when groups really try to work with real life problems, that is called complex unstructured problems, where it's actually not decided what resources you could use, what the objective should be, and so on. If you look at these situations, groups on average actually don't even outperform random interventions by a computer. These are, of course, simulation situations where a computer is simulating the development of a situation, and the groups try to deal with it. For example, the spread of an infectious disease or something in a country. So there's another interesting, rather late study that also sort of indicates a bit more what the problem is. Well, they've done this what's called neuro-IS studies, that is to actually try to see what happens in the brain when you cooperate with other people. And it has showed that people, in a situation, in a discussion where they're trying to cooperate and where they have a pre-discussion bias or a pre-discussion idea of the solution, they're not really influenced by what other people say. Then on average. Actually, we can see that there is no difference in the way persons treat facts contradicting their pre-discussion bias and the way they treat totally irrelevant information. It has the same brain reaction, and it basically says that the fact that they should process doesn't even reach what's called the prefrontal cortex, which is where this new knowledge or new information could start interacting with their existing knowledge in the brain. That is where things should happen if they are actually processing the knowledge. But now we can always criticize these studies for being experimental, and another way of looking at how good we are at cooperation is, of course, to study real work groups. And then we need to look at things in a bit of a different way, because you cannot, since groups have totally different purposes and objectives, we would rather have to look at indicators of knowledge integration and collective intelligence than actual results, because they're supposed to do different things. And now if we do that, we can see that the difference between groups, high performing teams at the level of 4 or 5 and average performing teams at the level of 3 in their focus on task is 100%, or that means that groups on level 4 or 5 actually spend 100% more focus on the task than the average work team, which is sort of gives us an understanding of how huge this variance in the use of knowledge are in different teams. We can also see that groups on grade 4 level, they spend 23 times more inquiring into the situation than groups at the level of grade 2. 23 times, that is 2,300% more inquiring into understanding the situation, which of course is quite an important factor if you're trying to find an intelligent solution in a complex situation. You can also see that comparing the same teams, grade 4 teams to grade 2 teams, the grade 4 teams would consider others related to the situation 27 times as much as grade 2 groups. Others related to situation could of course then be, for a normal group, could be others in the organization, it could be customers, it could be other departments and so on. And again, if you want to find an intelligent solution for an organization, that's quite relevant to sort of discuss, reflect, and consider how others are influenced by what you're doing, right? They would display 15 times more positive response to each other's input. That is, that the people in the group would actually react positively to others in the group 15 times as much. And here again, you can understand in a very simple way that if you're talking to other people and you're saying things that you believe are important, the reaction of those people would sort of be quite important for your continued contribution in the process, right? Which is also what we see. So positive response is important to keep the knowledge flow and the knowledge integration going. And all in all, this would result in these teams, these grade 4 teams, they would have in practice 78% higher influence on each other. And again, that's another indicator of collective intelligence, because if you're not influencing each other, if you're talking, discussing, but you don't really influence the ideas and the decisions of others, well, there aren't really any purpose of that knowledge integration. It doesn't really result in anything. So you need influence in order to integrate knowledge. Now, what are the factors here? We're going to talk about this in all the other lectures basically, but what are the factors here that decides what level of intelligence that different microsystems reach? Well, there are things like cognitive factors, the way people understand, the way their different perspectives and understandings of things. This can never be the same between two individuals. So you could say, in essence, the challenge of any group is to have as different perspectives as possible, but still be able to integrate them. That, in theory, would give the group the sort of highest level of knowledge to process, right? Now, unfortunately, having different perspectives actually normally means it's going to be harder for people to communicate. We have psychosocial factors. If people exchange knowledge, they are under constant influence of their own emotions and their reactions to other people. That means that knowledge integration can never be separated from the social process of the group. How good the relations within the group are actually supporting this process. Even if we think about ourselves as being rational and able to be fact-driven and so on, it is not the case. It is impossible to be that. So the more relevant strategy to any group would actually be to try to create the relations that are relevant and necessary for advanced knowledge integration, because we cannot turn off our influence of the social process. Then, of course, like we normally perhaps think about organizations, there are numbers of structural factors that influence this process of creating intelligence in a microsystem. It is what people work for, or if there are different reward systems, different organizational belonging, and so on, and the way the organization is trying to coordinate things using structure. This will, of course, also influence the teams. But it's also lack of structure. If you think about one of my early work experiences, when I was working early in my career, I was working for a large American consulting company called Accenture. We were developing IT systems for very large organizations, and I was part of a project, a very large project here in Sweden, where we needed experts and specialists from basically all over the world. So we had people who were very skilled in a certain part of this system and coming from different countries and work here for us and with us in this project. And if you just think about how we treated this situation, you could say we were flying in specialists and consultants that cost a lot of money every hour they were working, and we just put them into a conference room and had them start working on the problems, which is treating the fact that a microsystem or a group could end up anywhere on the scale of that, you remember that normal distribution between 1 to 5, as a happening, right? These cooperative situations could become really intelligent, or they could become really unintelligent, and this was nothing that we had any strategy or structure to work with, which is basically what I'm describing is the case in most organizations today. So the lack of structure, the lack of tools to ensure high level of collective intelligence is of course also a performance factor in organizations. So if we summarize lecture 2, organizations are enacted through series of parallel moments of individuals interacting in relation to the organizational structures and each other. We call these moments of interactions microsystems. Microsystems can be seen as the final step of the organizational process, where the structures are supposed to come alive. The advantage of a focus on microsystem level is that it will bring previously unattended factors into organizational management. For example, the psychological and physical status of individuals, the focus and understandings of individuals, skills in listening and communication, and things like that. There are a number of possible impediments for knowledge integration at microsystem level. These could be cognitive, psychosocial, structural, or lack of structure. Since microsystems are local, organizational strategies for microsystem performance must be directed towards the participants.